Alright guys, today's essential question is, how do we use derivatives to sketch the graphs of curves? Obviously, in order to do this, we're going to have to remember the first derivative test and the second derivative test. Remember, the first derivative tells us where the function is increasing and decreasing. When the derivative is positive on an interval, that means the function is increasing. When the derivative is negative on an interval, that means it's decreasing. The second derivative tells us about the concavity of the function. If the second derivative is positive on an interval, that means it's cup up, smiley face. And if the second derivative is negative on an interval, that means it's cup down, sad face. Now, these are just some guidelines to help you when sketching a curve. Think of it as like a checklist. Now, you won't have to use this on every single problem, but it's kind of like a help to guide you through the problem. First thing you want to look at is the domain, any x and y intercepts, any horizontal and vertical asymptotes, intervals of increasing or decrease, and local maxes and mins. Both of these you would find using the first derivative. And then concavity and points of inflection, you would use the second derivative to find those values. So let's take a look at a function, x to the fourth minus 4x cubed. Well, first of all, I know this is a polynomial, so the domain is simply all real numbers. So that means the function is continuous on the domain. Now the x and y intercepts, the way that we find the x-intercept, so to find the x-intercept, we set the y equal to 0, so the f of x equal to 0, and we solve for x. So if I set the y equal to 0 and solve this, I notice that there's a GCF of x cubed, and so that's going to leave me x minus 4. Set each one of these equal to 0, so I get x is 0 and x is 4. So I have two x-intercepts. The points would be 0, 0, and 4, 0. Okay, so those will be my x-intercepts. To find my y-intercept, you set the x equal to 0, and you solve for y. Well, if you set x equal to 0 in this problem, you're going to get 0 minus 0, so you're just going to get y is 0, so my y-intercept would be 0, 0. So the domain is all real numbers, the x-intercepts are 0, 0, 4, 0, and the y-intercept is 0, 0. Now, because this is a polynomial, there are no places where it's undefined, so there are no vertical asymptotes, and also there are no horizontal asymptotes. So we're good for this. For intervals of increasing and decreasing, we're going to have to find the first derivative. So let's find the first derivative of the function. So f of x is equal to x to the fourth minus 4x to the third. So the derivative of this would be 4x cubed minus 12x squared. Now, whenever you're talking about critical numbers, you want to see where the derivative is undefined. Well, that's not the case in here because it's a polynomial, but also where the derivative is 0. So I set it equal to 0. I notice I can factor out a 4x squared, and that's going to leave me x minus 3. Set each one of these equal to 0, and I'm going to get x is 0 and x is 3. So those two numbers need to go onto my sign chart. So 0 and 3. So I'm going to test -1, I'm going to test 1, and I'm going to test 2. I'm sorry, not 2. Let's go with 4. Okay? All right, and we're going to figure out what these values are and get my sign chart ready. So if I plug -1 into the derivative, this is going to be a positive. So -1 minus 3, that's going to be negative. So this is negative. If I plug 1 into here, that's still going to be negative. And then if I plug 4 into here, that's going to be positive. So that tells me that the function is decreasing. It's still decreasing, and then it increases. There is a min at x is equal to 3, right? Because it's decreasing and increasing. The derivative changes signs. Now, to find the point, because it's x is equal to 3, how would I find my y value? I would take this value of 3, and I would plug it into the original function. So I'd have 3 to the fourth minus 4 times 3 cubed, and that's going to give me -27. So the point would be 3, -27. Okay, so let me pull back this. So the intervals of increasing and decreasing, it would be decreasing from -infinity to 3 and then increasing from 3 to infinity. There are no maxes, but there is a min, and that min is at 3, negative 27. All right, now to find concavity, we're going to have to take the second derivative. So let's keep my function. My function is f of x equals x to the fourth minus 4x cubed. Okay, we took the derivative of that, and the derivative of that was 4x cubed minus 12x squared. The second derivative of that would be 12x squared minus 24x. That is not undefined anywhere, so let's just take it and set it equal to 0. I notice I can pull out a 12x, and that'll leave x minus 2. If I set each one of these equals to 0, I get 0, and 2 is my critical numbers, so those 2 points are going to go on my sign chart. All right, so I'm going to pick numbers on each of these intervals to test. So I'm going to test -1, I'm going to test 1, and I'm going to test 3. So if I plug -1 into here, I'm going to get a negative and a negative, so that's going to be a positive. If I plug 1 into here, I'm going to get a positive and a negative, so that's going to be a negative. And then if I plug a positive 3 into here, it's going to be positive and positive, so I'm going to get a positive. And so what this tells me is that this function is cup up from negative infinity to 0 and from 2 to infinity, and it's cup down from 0 to 2, and also there are POIs, point of inflection, at 0 and at 2, because notice the second derivative changes sign. So I want to figure out what that point is. So 0 is one point and 2 is the other point. So we're going to plug 0 into the original function, 0 minus 4 times 0, so that's going to be 0, which we found that point earlier. And now if we plug in 2 into here, to the original function, 2 to the fourth is 16, and then 2 to the third is 8. 8 times -4 is -32, so you got 16 minus 32, so that'll be -16. So that's where my two POIs are. So let me pull back this form again. So again, it's a cup, what we say it was cup up from negative infinity to 0. And then from 2 to infinity, it's cup down from 0 to 2. And then there are POIs, point of inflection, at 0, 0, and at 2, -16. Okay? All right, so now we're going to sketch a graph of this curve. And actually, I've already got it on the next slide. And this would be it right here. Notice that the x-intercepts are at 0, 0, and 4, 0. Notice that there is a point of inflection at 0, 0, and 2, -16. There's also a minimum value at 3, -27. And then notice that the graph is decreasing, decreasing, then increasing. And then notice it's cup up, cup down, and cup up. So we were able to use all that information to sketch a graph of the function.